So we just discuss about the concept of the things that we are using in the Rutherford experiment, and we use just the fluorescence screen to detect the beam of alpha particle. Now, if we talk about the question that actually used to be asked in your exam related to the Rutherford experiment, so that question is related to the concept. Okay, Mayer, you got the idea that what is fluorescence screen?
Yeah, I did.
Okay. You can consider just like the X-ray films that we use to do the X-rays, because that also leaves the traces on that sheet.
All right.
Okay, we just use a shiny type material on any surface. So when some radiation or light passes through that, so it leaves traces over there, right? Because we are not able to observe the radiation by our normal eye. So definitely we use some sort of material that gives you the traces of or identification of that particles after they pass through that. Okay. So in exam, if they ask about the observation that what Rutherford observed from this experiment, so during the observation, we observed that most of the alpha particles were able to pass undeviated, right? So most of the alpha particle were able to pass undeviated. And the second thing is a few deflects at large angles. And the third one is, I know that you are just focusing on the statement that was given by the Rutherford, and very few of them bounced back. So these are three main observation that we just note down from the experiment, and that is also shown in the videos also, because that are like animated video that are also made up from these all observations, right? So basically, what we actually got from these observation, so let's suppose if they ask that what you deduce from these observations of the experiment, so we can say that atom is mostly empty space, right? There is nothing in atom. Most of the part of the atom consists of empty space, right? Atom is mostly empty space, right? There is nothing in the atom. And second thing is a very small and dense positively charged nucleus exists in center. And the final thing that we already discussed, that electrons move around the nucleus, right? So this is the concept. And if we talk about reasons, let's suppose if they ask about the reason that what do you think that what are the reason behind all this behavior of the particles? So if they ask about the reasons, so we can say that most alpha particle cross through the empty space of atom, and the second, because we know that those beam of alpha particles that reaches the central part, they got completely reflect back, right? And why they reflect back? So we have to answer this one. So we can write those which approach near the nucleus deflected due to repulsion. And why there is a repulsion process? Any idea why we are writing the concept of repulsion?
Because alpha particles are positively charged,
Yes.
and
And
then I think the nucleus is also just positively charged.
yes. Any other idea that you want to share?
Sorry, may you repeat yourself, please?
Basically, the question is that the second point, if you consider the second point, those which approach near the nucleus, deflection due to repulsion. So basically, this is deflected. So why those particles that reach the central part, they just deflected back due to repulsion. So why there is a concept of repulsion? So one answer I got that alpha particles are positive charge and nucleus is also positive charge.
Like charges repulse
Yes,
each other.
because in the previous,
Same force is repulsed.
yes. So basically in deduction paragraph, we discussed that a very small and dense positively charged nucleus exists in center, right? So that's why it completely reflect back because same charge repel each other, right? Just like the north pole of the magnet repel each other. Okay. And
Would there be any other reasons, sir?
yes,
Would there be any other reasons?
no, basically this is very basic points that we are talking about. We are not talking about very advanced concept over here. So because I am writing deflected due to repulsion and there is no concept of repulsion till now. So basically the idea of repulsion came from the concept of positive charge, right? We will discuss further detail in the next chapter of radioactivity. But for the time being in this Rutherford experiment, you don't need to explain further detail about this concept, right?
Okay.
And the last point, those which approached, we can say the boundary of the nucleus, approach to the nucleus, they just bounce back due to repulsion, right? So these are some observation, deduction, and some reasons that was completely derived from Rutherford experiment. And this is the statement of the Rutherford in a lecture during at Cambridge University. He used to say that it was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as he also gives you the comparison that what actually he feels and how this experiment feels like. So he mentioned that if you fired a 15-inch shell at a piece of tissue paper and it just come back, right? So this is the same type of thing that he observed during the experiment and what he feels during this experiment, right? Because you know that atom is a very smallest particle, right? Even we are not able to observe with our eye. So if you observe a very common example like the tip of the thumbprint, right? So you are able to observe that thumbprint, tip of the thumbprint, right? So, if you just strike alpha particles on any substance or any atom that is like not visible even all, so when it reflect back something, so you know that a very small particle you found that which gives you that particle back into the same direction, right? So it is like something invisible thing over there. They just reflect back you something in the same direction, right? So I realized that this scattering backward must be result of a single collision. And when I made calculation, I saw that it was impossible to get anything of that order of magnitude unless you took a system in which the greater part of the mass of the atom was concentrated in a minute nucleus. It was then that I had the idea of an atom with a minute massive center carrying a charge. So this was the statement given by the Rutherford during the lecture at Cambridge University, right? So by his own statement, you can compare the real experiment that what was that experiment at that time. But nowadays we feel this one as a very common thing, a very basic concept, because in our exam it only contains few marks. So that's why it is a very simple topic for us. If someone have some interest in the nuclear physics or in some radiation, just like the Oppenheimer or the other one. Okay, so any question?
Oppenheimer is such a long movie. I can't find time to watch it.
Yes, because in old ages, you know that when all scientists are try to discover something new, because nowadays we
Yeah.
don't have something new to discover, right? We can only just innovate it, right, in a different way. So we are not able to like discover something new, right? If you try to discover something new, So you will waste more time in discovering something new. So it is better to innovate the old ideas in something new form, right? Because 99.99% almost all things are discovered. So it is better to innovate the old idea uh, in short time as compared to that you will try to find something, discover something new. Because in nowadays, because in PhD level or at MPhil level, you know that students and the teachers who are doing PhD in two or three subjects, so they write down the research paper, right? So do you think that all of them are
Yeah,
working on different topic, right? They are not working on different or very new
they were
concept.
on the same topic. Yeah,
Yes, they just take the publications or old papers from something that was written over there and try to innovate with some new calculation, because nowadays we are using AI. So some one just use the old concept and merge it with the AI to get automated result, right? So these types of things we used to do in our daily life. We are not working to invent or to discover something new. Okay. So if you consider a few questions, because this chapter is, you can see that there are only 40 pages for the MCQs from from these two chapters. So the first one is, which statement about a nucleus of neutron is correct?
C.
Okay, C. So basically 15 represents you proton plus neutron, and 7 only represents you proton, right? So 15 minus 7 you need to do for neutron. So there are 7 protons and 8 neutrons, right? Any confusion? Okay, because this is very simple one. And this is related to isotope. Okay, this is related to radioactive material, alpha particle. Yes, 5. A beam of alpha particle is fired at a very thin sheet of gold foil in a vacuum. What is deduced from this experiment?
B.
Yes, because you observe this term that we use the same term in our explanation. So what is deduced from this experiment? Nuclei are much smaller than atoms. Because in first option that is given, alpha particles are repelled by electron. That is not possible. Atoms contain air. This is not mentioned in the experiment. Electrons are found in atomic nuclei. This is also not the part of that theory, because electrons are moving around the nucleus, not exist in the nuclei. And nuclei are smaller than atoms. So this is the point that we deduce from that experiment.
Sir, I have a question.
Yes.
You told us that the nucleus is positively charged, right? And the
Mhm.
particles are also positively charged. So why aren't they attracted to the electrons because they're negatively charged?
Because if you remember the concept of the circular motion, right? So
Yeah.
basically, circular motion, what we discussed, that if you just tie a string with the stone and try to apply force on it, so basically you are not applying force in a circular way, just like the stone is moving. Because of that thread you are holding in the center, so that is responsible for the motion of that uh, stone or particle that is connected with the string. So when you try to figure out this motion of the electron and with the nucleus, so basically in the nucleus we are having proton and neutron. Neutrons are neutral, right? So there is no charge on it. So basically the central part is mostly positively charged, right? Densely positively charged, that we mention over here. And electrons are moving around it. So basically what happens with the electron, because there is definitely some mass of electron, right? Because we are working on nanoparticles, so according to that there must be some mass of electron, right? It is equals to 1.6 exponent minus 27 kg, but still there is some mass of electron, right?
Yeah.
So that mass acts in some direction. You know that weight always act in central direction, and this positive charge tries to attract this electron, right? But due
Yes.
to its own field, and due to the positive and the negative field, because it is also moving in orbit, and that positive charge try to attract that negative charge to the center. So due to these two forces, it starts to move in a circular path around the nucleus, just like the example of the earth, right? Because sun tries to attract everybody in the solar system, right? But the
Yes.
natural motion of the body is like a normal motion. So when these two forces are acting on the body, so due to the resultant force, so that resultant force will give you the idea of that circular motion. Okay, because there are two forces like this that are acting on the electron, and this topic is also included in your A2, because in A2 we are going to discuss all these scenario, that how this will happen, because there is also electromagnetic field in our surrounding, right? So that electromagnetic field will also affect the motion of electron. Okay, so due to these forces, in simple words we can say that the resultant force acting on the electron, so that helps the electron to move in a circular path. Okay, and the attraction force of that positive charge on electron, that gives you the centripetal force to electron to move in a circular path, right?
Yes.
So this is the basic concept. We will discuss about mass also in the next chapter, because this chapter is almost like the same. We are not going to do like a different chapter, separate chapter. And a neutral atom of chlorine 37 is compared with a neutral atom of argon 37. How do you, how do the number of electrons and number of neutrons
Okay.
in each of atoms compare?
A.
Okay. So they are asking about number of electron and number of neutrons. So because you know that chlorine and argon, they just relate with some different group, right? So it also contains different number of proton, different number of neutrons. So definitely the number of electrons will also be different, right? So that's why the number of electron and number of neutrons will be different. Okay. So these are basic type of question that is included from the first chapter. And the next topic that we are going to do in this chapter is related to the isotopes, right? So you also know about basic idea of isotopes. Okay. So next time we will start from the concept of isotopes. Okay.
Okay.